Thank you, Sean and Janan, for inviting me. It's really nice to be here. The assignment that I understood myself as getting was to say something about the foundations of physics, and also I take it to say something in the spirit of this unique and wonderful conference that bears on very large questions of who we are and how we fit into the world and how everything hangs together at the most general imaginable level. And so I thought it might be appropriate, and I'm hoping it might be helpful to say something about the relationship between the fundamental laws of physics and the idea of agency. What I want to talk about in particular is what you might call the practical asymmetry between the past and the future, the asymmetry that we alluded to and that Sakshi alluded to in her comments this morning, um, when we say, for example, that the future is open in a way that the past is not, or that by acting now we can affect or shape or control the future in a way that we cannot affect or shape or control the past, or that causes are in the pasts of their effects. And all I'll have time to do here is to share a few of my own convictions and intimations and uncertainties, for whatever they may be worth, about the business of figuring out where this particular asymmetry comes from and what it amounts to. The sorts of things that people have had to say about the origin or the explanation of this asymmetry can be divided, I think, into three general categories. There is, to begin with, a tradition of thinking of these asymmetries as built into the fundamental metaphysical structure of the world. Views like that are represented nowadays by what McTaggart called a-theorists of time, or by growing block theorists of time, or by moving spotlight theories of time, or by presentist theories of time. But they go back a long way, views like this. Whoever is inclined to agree with Aristotle that there's no fact as of now about who wins the sea battle tomorrow, and whoever is inclined to agree with Newton that time in and of itself and of its own nature passes, is going to fall into this category. And then there's a view located, you might say, at the exact opposite end of the spectrum, to the effect that, as Hugh Price puts it, causal asymmetry isn't really in the world at all, but the appearance that it is a product of our own standpoint. And a lot of what I want to say here boils down to the conviction that both of those views are wrong, and that the right way of thinking about where this practical asymmetry comes from is somewhere in between them. The obvious trouble with the idea that these asymmetries between the past and the future are somehow built into the fundamental metaphysical structure of the world, the obvious trouble, that is, with the idea that these asymmetries between the past and the future come from somewhere even deeper down than the fundamental laws of physics, is that it's hard to see how asymmetries like that, even if one could say something intelligible about what those asymmetries amount to, and even if those asymmetries were really out there in the world, it's hard to see how they could play any role at all in explaining the capacities of embodied agents to affect things or to control things. Maybe this is worth spelling out in just a little more detail. The trouble is that the business of ensuring that this fundamental metaphysical asymmetry between the past and the future is compatible with the fundamental laws of physics is going to require that the metaphysical asymmetry leaves no trace whatsoever of itself on anything like the motions of particles, or on anything that supervenes on anything like the motions of particles, in what people say, for example, or in what they write, or in what they push around, blood or in the pattern of electrical excitations in their brains. And so, on a view like this, the fact that there is a fundamental metaphysical asymmetry between the past and the future is apparently going to be barred from playing any role at all in the business of explaining our impression that there's a fundamental metaphysical asymmetry or any kind of asymmetry at all between the past and the future. All right, let's jump then to the other end of the spectrum. Many people have been arguing for many years that the practical differences between the past and the future are best understood as a matter of perspective or of the point of view of whatever particular agent we happen to be concerned with. Here, for example, is a representative quote from Hugh Price. The essential asymmetry of agency belongs to the internal perspective, to the experience of being an agent. From the inside, as it were, we perceive a difference between what, in the standard temporal frame, will be described as the inputs and the outputs. The inputs appear as fixed or given, while the outputs are what is open or potentially subject to our control. It's important to stress the subjectivity of this, for the point was that no such difference between inputs and outputs is apparent from the atemporal perspective. An Augustinian God just sees a nexus for a complicated structure of correlations. The difference between the fixity of inputs from the past and the openness of the inputs from the future is a feature of the experience from the inside, a feature of what it feels like to be an agent, close quote. And I guess I should acknowledge right up front that I don't have any particularly clear idea of what this is supposed to mean or how it's supposed to work. But it'll suffice for my purposes here just to say that whatever it is, I'm pretty sure I'm against it. I'm convinced, that is, that what we're trying to explain when we try to explain the various practical differences between the past and the future is not a matter of point of view and not a matter of the metaphysical character of time, but a mechanical phenomenon of nature. I'm convinced, to put it slightly differently, that what we're trying to explain when we try to explain the various practical differences between the past and the future is not a topic for phenomenology, and it's not a topic for conceptual analysis, and it's not a topic for metaphysics, and it's not a matter of perspective, but that it's an old-fashioned, objective, third-personal, a matter for old-fashioned, objective, third-personal empirical science. Imagine that you were to discover that by waving your arms around here, by waving your arms around, that is, wherever you happen to be standing, you can affect things to your north, but not to your south. And consider what a satisfactory explanation of a phenomenon like that might look like. Consider what kind of an explanation of a phenomenon like that you would be inclined to demand. And the point of everything I've been saying so far is that we're entitled to exactly the same kind of explanation, that we should demand exactly the same kind of an explanation of the fact that by acting now, we're able to influence the future, but not the past. And once we're agreed on that, the differences between the existing approaches, insofar as I understand them, start to get pretty small. Once we're agreed on that, to put it slightly differently, the differences between existing approaches seem to me to amount to differences about the level of scientific generality at which one expects the best and most perspicuous and most illuminating explanations of these phenomena to emerge. My own hope and my own instinct has been that the right place to look for an explanation of the various practical distinctions between the past and the future is not in the sciences of perception, and not in the sciences of cognition, and not in the sciences of deliberation, and not in the sciences of life, but in the fundamental laws of physics. And if I'm pressed to say something about why I have this instinct, if I'm pressed to say something about where this instinct comes from, what I want to say is that the asymmetry we're dealing with here feels somehow unmistakably universal. We're not at all surprised to learn that there are creatures who are stronger and faster than we are, or who can see or hear farther than we can, but we would be flabbergasted if we were to ever encounter dolphins or bacteria or extraterrestrials or automata, no matter where they came from, no matter what they were made of, no matter how they were built, whose practical relationship to the past and the future was something like the inverse of our own. The thought is that whatever it is that stands in the way of there being creatures like that is something very general and very deep. And what this suggests is, again, that the place to look for an explanation of this particular asymmetry between the past and the future is in what we know and what we can guess of the fundamental laws of physics. Let's have a look then at what the fundamental laws of physics might tell us about that. And here, this one happy coincidence is that this hooks up nicely with the talks by Alan and Sakshi this morning. It overlaps with them to some extent. It'll differ from them in other extents, in other ways. And here's one. The contraption for making inferences about the world, the contraption for drawing conclusions about the world, that fundamental physics has to offer us, insofar as any rate that we can tell at the moment, is going to consist, I'm usually thinking, of three basic components. And here I'm going to be adopting the components that were suggested by Feynman in the lecture that Professor Guth quoted from during his talk, where Feynman thought that what we're going to have to do is add as an additional law-like stipulation that there was a moment at which the entropy of the world is very low. So here are the three components of the contraption for making inferences. One, a space or a set of possible exact physical states of the universe as a whole, and a dynamics that determines which particular transitions between those states are physically possible and which are not. Two, a so-called statistical postulate, which stipulates a probability distribution over the space of possible exact microscopic physical states of the universe as a whole. And three, and this is where I'm going in the Feynman direction, a so-called past hypothesis, which stipulates that the universe started out, or that our epoch of the universe started out, in some particular very low entropy macrostate. If there's a way of dispensing with this hypothesis, and this is what Alan and Sean and Sakshi, this is the kind of hope that Alan, Sean, and Sakshi are offering. I think that's great. If it turns out that we have a way of doing all the jobs that this past hypothesis can do without specifically invoking it, I think that's great. There are lots of things about the suggestion that Alan was talking about this morning that I don't fully understand, but if something pans out in that direction, I think that's great, and it's not going to change very much of the rest of what I have to say. Note that these three components taken together are going to assign a definite numerical probability value to every formulable proposition about the physical history of the universe. And that probability assignment is nowadays referred to as the mentaculus in the literature, after the name of a notebook of a psychotic character in a Coen Brothers movie called A Serious Man. And the way, because he referred to it as a probability map of the universe. And the way that this mentaculus contraption is applied to the business of evaluating what we can and cannot affect by acting now about the condition of the world at other times is presumably going to proceed something like this. You start with some sensible algorithm for evaluating counterfactual conditionals. Which particular such algorithm one starts with shouldn't matter much. The important thing is that the exact algorithm, whatever it might turn out to be, not introduce any asymmetry between the past and the future over and above the asymmetry which is introduced by the hypothesis that the universe started out in a state of very low entropy. The important thing, to put it slightly differently, is that the fundamental law is that it be the fundamental laws of physics themselves which are doing all the work of explaining why it seems to us that we can affect the future, but not the past. Anyway, once such an algorithm for evaluating counterfactuals is in place, you apply it to the business of evaluating the capabilities of agents to bring this or that about in the context of a complete deterministic fundamental physical theory of the world, like, say, Newtonian mechanics, by means of an appeal to what I would call a fiction of agency. You start out, that is, with some primitive and unargued for and not to be further analyzed conception of which particular features of the present physical condition of the world it is that are to be thought of as falling, as it were, under some particular agent's direct and unmediated and freely exercised control. And the question of what that agent is capable of bringing about will then come down to the question of what the above-mentioned direct and unmediated and freely exercised control can be parlayed into elsewhere and at other times under the circumstances in which the agent finds himself by means of the fundamental laws of physics. We tend to think of ourselves as exercising the sort of direct and unmediated and freely exercised control I'm talking about over, say, the positions of our hands and feet and fingers and toes, or if we're being still more careful, over the tensions in various of our muscles, or if we're being more careful still over the electrical excitations of our motor neurons, or if we're being even more careful than that, over conditions in various regions of our brains. But we never ever think of ourselves as exercising that sort of control over so much as, say, a single molecule of the air in the room. Whatever control we have over that will invariably strike us as indirect. Whatever control we have over that will invariably strike us as mediated by the laws of physics. We're going to want to make certain, as with the algorithm for evaluating counterfactuals, that whatever particular fiction we choose does not introduce any new asymmetries of its own between the past and future. But aside from that, the details of these fictions aren't going to matter much for our purposes here. All that's going to matter, as it turns out, is that the set of present physical properties of the world over which we think of ourselves as exercising this direct and unmediated sort of control is invariably exceedingly tiny. All that's going to matter is that the set of present physical properties of the world over which we think of ourselves as exerting this direct and unmediated kind of control constitutes a negligible fraction of the totality of physical properties of the world at present. And moreover, that the particular properties in question are invariably properties of relatively small and localized physical objects, neurons, say, and not buildings or atmospheres or planets or galaxies. And what we're presumably going to want to show, and all we're presumably going to need to show if this program works out, is that large and significant aspects of the future, but not of the past, can sometimes counterfactually depend on relatively small differences in the present, like, say, different positions of my fingers or different tensions in my muscles, and so on. So that, an extremely rough outline, is the program. And there are good reasons for being optimistic that something along these lines is eventually going to work out. But that having been said, the interesting recent developments in this investigation all have to do with the fact that the program does not seem to be unfolding exactly according to plan. Consider, for example, the following objection, which is due to Adam Elga. Elga has pointed to a class of situations in which, on this account, every corner of the present is positively swarming with opportunities to influence the past, and to influence it, mind you, on a grand scale. Suppose, for example, that the continent of Atlantis, as a matter of actual fact, once existed, but that every readable trace of that existence has long since been wiped out, and that the probability that there ever was such a continent of Atlantis that one would obtain by conditionalizing the mentaculus on every piece of evidence available to us in the present, the probability that there was ever such a continent as Atlantis that one would obtain, that is, by conditionalizing the mentaculus on the complete present macro condition of the universe, together with the present contents of the memory of everyone living, together with whatever other more or less directly surveyable features of the world you like, suppose that probability is astronomically low. Mind you, since we're dealing here with a fully deterministic and time reversal symmetric fundamental microscopic dynamics of the world, there can of course be no question of wiping out every trace whatsoever of the fact that Atlantis once existed. What Elga asks us to suppose is rather that what traces there still are now thoroughly dissolved, as it were, into the global microscopic structure of the world. That what traces there still are now confined to impossibly complicated mathematical combinations of individual positions and momenta of more or less every subatomic particle there is. Elga points out that under these circumstances, the property of being a world that once contained an Atlantis is going to be astronomically unstable, even under very small variations of the world's present state. And so, on the sort of account that's being suggested here, it will apparently come out true that if I had snapped my fingers just now, or if I had had something other than tuna fish for lunch yesterday, or if a certain particle of dust on Mars had zigged this way rather than zagged that way on June 6, 1997, the continent of Atlantis would not have existed. There are, mind you, ways of dealing with this objection. Note in particular that Elga's story depends crucially on the premise that every readable trace of the existence of Atlantis has long since been wiped out. Because if every readable trace of the existence of the continent of Atlantis had not long since been wiped out, then the probability that there ever was such a continent as Atlantis that one would obtain by conditionalizing the mentaculus on the evidence available to us in the present would not be low, and the property of being a world that once contained an Atlantis would not be unstable under local variations of the world's present state. Unless, of course, those variations happen to affect those readable traces of the existence of Atlantis themselves, and it would certainly not have come out true on the sort of account I'm suggesting that if I had snapped my fingers just now, the continent of Atlantis would not have existed. There are particular circumstances then in which the historical existence of the continent of Atlantis depends on my not having snapped my fingers a minute ago. But it happens to be part and parcel of what particular circumstances those are that I can have no way whatever of knowing, and I can have no grounds whatever for suspecting when it is that they actually obtain. And so the dependence in question here is of a kind that can never be put to any empirical test, that can never be exploited for any practical purpose, and whereby we can never have any effect on the probability that we actually assign to the proposition that any such continent as Atlantis ever existed. Okay, but there are other objections. I won't go into them in detail. The ones I have in mind are due to figures like Matthias Frisch and Alison Fernandez, which necessitate further clarifications of precisely what it is that we're trying to show here. And these successive clarifications seem to have begun to look more and more like makeshift bells and whistles, or like the addition of epicycles, or like a discouraging game of whack-a-mole to some investigators, and to suggest that it might be better, and there have been suggestions that it might be better to back up and start things off with a more sophisticated treatment of the phenomenon of agency closer to the center of the stage. On these approaches, which have been explored especially insightfully by Janan Ishmael and by Alison Fernandez, the very naive and schematic fiction of agency that I alluded to above is replaced with a picture of agency that carries a fairly rich temporal structure, in which, for example, decision lies temporally between deliberation and action, and fairly detailed epistemic requirements in its very essence. And much of what may have looked like ad hoc bells and whistles on the earlier approach is argued to emerge in this one from the very idea of what it is to be an agent. My own guess at the moment is that the disagreement here doesn't run very deep, and that these two trains of thought, as we learn more about them, may yet turn out to converge. But we'll have to wait and see. Wow, I'm ahead of time. One quick closing remark. Pays to read. One quick closing remark. Many people have wondered whether recent advancements in the development of very general and very powerful techniques for reading causal structure off of conditional probabilities, the advances associated with figures like Jim Woodward and Judea Pearl and so on, might be of help here. I've tended to think not, since, for example, those techniques often treat time order as a fundamental constraint on what can causally affect what. But I'll be eager to hear more about that from my commentator, Naftali Weinberger, who knows a great deal more about these techniques than I do. Thanks.
Thank you so much to the organizers for planning such an excellent conference and for inviting me to comment. And thank you to David for opening the door for me to say a few words about how the causal models that I and many people tend to work with, how they relate to the types of issues he was talking about. Now, I think the first helpful thing I could say here is while the whole discussion in philosophy of physics tends to be on the asymmetry of time, or the arrow of time, a curious feature of causal models is they don't necessarily make any reference to time. Now, this tends to surprise people, but what I mean by this is if you have a causal model, so say C causes E, some people look at this and they think this just entails that C comes before E, and that maybe even that what it means for the arrow to have direction is some fact about time. But in fact, all of the empirical implications of models like this are probabilistic implications, facts about conditional independencies. So the implication of a model like this is that if C causes E, causes of C, such as X, are correlated with E, but X and E are uncorrelated given C, while causes of E, such as Y, are uncorrelated with C, but C and Y are correlated given E. Now, don't worry if you didn't get all of those details. The point here is that when I'm talking about the asymmetry of causation, I'm not saying anything directly about time. The asymmetry of causation is the fact that causes of causes are correlated with their effects, while causes of effects are not correlated with their causes. Okay, and what this means is that even if you choose your favorite account of the direction of time, you still haven't yet, just by doing so, given an account of the causal asymmetry, and there's still a lot of work to do in figuring out why is it that the two arrows match. So why is it that causes precede their effects? So now today I want to talk a little bit about, well, why, about how do we understand the direction of causation. And I think David's actually totally right that if you look at most of the literature here on causal modeling, it's not going to be that helpful if we're engaging with the type of project that he's doing. So Nancy Cartwright famously said, no causes in, no causes out. So you can't get causal conclusions without causal assumptions. And I think that's right. But that being said, I think there's a lot more to be said than has been said about how to relate the content of causal models to facts about the world. So today I'm going to very briefly walk through how I think we should do so. And my basic approach is that we learn a lot about causal models by looking at how our causal representations change as we vary the spatiotemporal scale at which we consider a system. So I'm going to look at a particular causal modeling framework, dynamic causal models, due to Herbert Simon and Yumi Iwasaki. And I'm going to show how the models change as we zoom in or zoom out, or as we coarse grain and fine grain, if you prefer. Okay, so I'm going to start with a nice example due to Simon and Nick Rescher. So here we have the amount of wheat that's grown in a field, depending on the rainfall and the amount of wheat that's planted. So here, rainfall is an exogenous variable. So that just means that wheat depends causally on rainfall, but not vice versa. And this looks like a pretty good example of an exogenous variable. But if we think about these as repeatedly measured quantities, and if we think about a really long time scale, say 50 to 100 years, over very long time scales, agriculture does influence climate. So over long time scales, we might actually get a feedback loop where there should be some causal influence of agriculture on climate, of wheat on crop growth. So what's going on when I give everyone the first model and everyone except for audiences of climate scientists say that looks perfectly fine, that's an exogenous variable? I think pretty clearly what's happening is that we're implicitly considering the model at a time scale. If you just care about the next 5 years, then over the next 5 years, any influence of agriculture on climate is just going to be negligible. It'll be slow acting. You can just ignore it. Now, the exogenization operator is just a way of capturing that. It's a way of starting with the model on the right, where you do have a cycle, and moving to the model on the left. And you can think about that as zooming in. You start at a time scale at which the process has not had time to equilibrate, and then you zoom into a time scale at which the feedback loop is happening so slowly, you can just treat it as if it's not happening. Okay, so hopefully this example already gives you some sense of what I mean when I say causal models are relative to timescale. And hopefully it also gives you at least some vague sense about how this might give you some insight into understanding the content of causal models. So instead of just saying, oh, we're assuming this is exogenous, we're learning something about how exogeneity is a feature of the timescale at which we're observing the system. Okay, so the next operation is equilibration. And I'm going to give a different example. So imagine we have a bathtub at which water flows in at a rate of Q in and out at a rate of Q out. The bathtub has water at depth D and exerts pressure of P and has a drain of size K. And I'm just going to give you the model for this. So here we have depth causing pressure, which along with the size of the drain determines the rate of flow out. And when the rate of flow out is different from the rate of flow in, there's going to be a change in depth given by the time derivative of depth. And we can use the time derivative of depth to determine future depth of the water through an operation known as integration. Now, there's of course a lot going on in this model. So even if you know something about causal models, they usually don't include time derivatives. So I'm really skipping over all the details. If I were giving a longer presentation, I'd usually spend 10 minutes just on this. So I'm really just hoping the fact that I'm giving a fairly intuitive example makes this look somewhat right to you. You're willing to grant it to me. Because what's really going to be important here is how we move from this model to an equilibrium one. So the system does have an equilibrium. So if the water doesn't drain or overflow, there will be a point in time at which the rate of flow in is equal to the rate of flow out. So we can use equilibration to derive the equilibrium model for this case, given on the bottom. And that should look very counterintuitive. That should not be what you expect. But just to motivate it a little bit, it's really important to bear in mind that we're only considering these quantities at equilibrium. So you might think that it's just obvious that the rate of flow in influences the rate of flow out via depth. But, and you might imagine that you sort of change the rate of flow in, and now there's a period of time where the rate of flow in does not equal the rate of flow out, and the depth will change. But once that whole process reaches a new equilibrium, the only thing that the new rate of flow out will depend on will be the rate of flow in. So to start wrapping your head around this model, the really important feature is that you're only considering the variables at equilibrium. Okay, so the big picture here is we could think about going from the top model to the bottom one as a form of zooming out. You start at a time scale at which the depth has not reached equilibrium, and you zoom out to a time scale at which you assume that all the variables have had time to equilibrate. Okay, so on my very last slide, I'm going to stick with the same model and talk about what happens if we exogenize this. So imagine we exogenize D, and this amounts to zooming in and imagining we're in a world where we never reach equilibrium. And in the bathtub case, this is a bit strange. We're used to seeing bathtubs equilibrate. But, this is a thought experiment. Imagine we're living in a world where it happens very slowly, or we're in a giant bathtub, what have you. And all we observe are the relationships in the system that hasn't reached equilibrium. So here, exogenization will focus in on this part of the model in the box. So depth causes pressure, which along with the size of the drain determines rate of flow out. And those would be the causal relations we'd infer in this world. And I think what's kind of interesting here is that basically what we're saying is that this causal model, this causal system, is implicitly relative to a gradient, namely a gradient between the difference between rate of flow in and rate of flow out. And that might not be something we know. We might have to discover it. And the reason I find that interesting is I see some connection between that and the past hypothesis, because at least the way I understand it as a non-philosopher of physics is that we observe all these features of our world, we observe causal directionality. We don't know how to explain it just given the laws of physics, but in order to explain it, we need to posit a gradient, namely an entropic gradient given by the past hypothesis. And here I reach the point where I'm reaching the limits of my competence. So I'm not a philosopher of physics, so I'll need to rely on you to tell me whether there's something here. But hopefully that gives you enough in order to see how you might start relating the type of work I'm doing to the type of work that David and Alan are doing. So thank you very much.